Hello, this is the third part of the Cloud Native Ninja series. In the previous part, we started building the application and we built two services. One is the TechTalks producer and the other one is the TechTalks consumer using Dotnetcore as our preferred programming language. We also looked at Dapper, which is an event-driven mechanism or an open source project which allows us to build microservices and to allow us to interface with various different components. In the first part, we also looked at how we can create RabbitMQ on our development environment without installing any software related to the RabbitMQ using Docker. In this video, we are going to containerize or package our application, the producer and consumer, in the similar way as we use the RabbitMQ Docker image. So my name is Nilesh and let's get started. The first thing that we need in order to create our own container image is to have the application packaged with all its dependencies. And to do that, let me switch over to the browser and see how we can start to containerize a Dotnetcore application or .NET application which we built in the previous video. We go over to the .NET.microsoft.com, and if we scroll down here, we will see there are various things that .NET has to offer. And since we are building microservices, we will go into the microservices section, which contains the Docker images, the official Docker images which are provided by Microsoft. As we looked at the RabbitMQ image earlier, all these images, the official images, they are hosted on a container registry. It can be Docker, it can be other container registries. In our case, we are going to use the official image provided by Microsoft on the Docker container registry. So think of a container registry as a place which is used to publish images which are used by the consumers of those images. And most of the tools vendors as well as frameworks, they provide images in the public container registry like DockerHub. So if we head over to the .NET section, we can see under the .NET, there are various different types of repositories or images available. There is .NET SDK, which contains the .NET SDK for building the applications. It contains all the build tools and other things which help us to build. Then there is the runtime image, which contains ASP.NET or ASP.NET Core, the runtime version, which is used for running the application in production. We also have a generic runtime image. There is runtime dependencies, there is a monitoring tool image, and there are samples. So for this session or this video, we'll be using the SDK and the ASP.NET Core images. The others, you can go through the details in this page. So let's first look at the runtime image, which we will use as a starting point. Once we have identified which image we want to use, we can create a file which is called as a Dockerfile. That file contains the description or the steps which are required for building or packaging our application. So we are going to start with the runtime image, the ASP.NET Core, and it has got two tags. If you remember from one of the earlier videos, I had talked about how tags help in identifying the image versions. So there is a 6.0 tag which is related to the long-term supported version of .NET Core or ASP.NET. And then there is 7.0, which is the standard support. We can use Docker pull, then mcr.microsoft.com.net and ASP.NET with 7.0 as the tag. And this will give us the long-term supported version or the standard version. If we use 6.0 as the tag, we will get the long-term supported version. Since we built our two services, the producer and consumer, using 7.0 version, we will be using .NET 7 or 7.0 tag for that. So let's head over to the Visual Studio Code and let's see how we can start containerizing our application. Usually in our producer or whichever is the application, there is a file created which is called as the Dockerfile. That's the convention. The default name is Dockerfile, and there are different ways in which we can package the application. First thing that we do is to use the base image or the image which is provided by Microsoft. This is the first line where we say from, and we provide the name of the base image that we want to start building our application from. Now there are different ways in which we can package the application. First one is we can build the application like we did in the last video and just copy the release artifact or the output of that build step into this particular image. So that is done using the copy command, and copy command tells what is the source of the file or the directory and what is the target where we want to copy this. So when we say dot, whatever is under the release output, all those files, they get copied and at the root level of this directory or of this image, and then we invoke the entry point. Now copying will copy the contents of release output into the image. We still need a way to start that image. Once the image is built and once we create an instance of that which is a container, once the container starts running, that is when the entry point comes into the picture, and we specify which command has to be run and if there are any parameters which needs to be passed to that command. So we are going to start the image or the container by running .NET command, and then we pass the producer.dll which was copied from the release output. So in order to do this, I've created some of these commands in the markdown file if you want to follow along. The first thing we do is we create a release output. So let's head over to the terminal and first build this. So I have this terminal open, and let's go into the producer where we have this Dockerfile. So let's clear this and let's look at the current folder structure first. If I look at the contents of this directory, I'm currently under the src.net folder under the producer source code. So I'm going to build this or publish this producer. So I use the .NET publish command, and the configuration I use is release, and I output the contents of this release build into the release output folder. The output is generated, or the release is, the application is published, and we see under the producer folder there is a new bin release .NET 7.0 producer DLL is created, and there is also a folder called release output which is created. So if you go back to our Dockerfile, the thing which was copying was from this folder. So the step which we mentioned saying you base the base image on ASP.NET 7.0 and then copy the file. So once we have the release output, we can copy it. Now, those are the instructions in the Dockerfile to specify how the application has to be packaged with all its dependencies. So in our case, we only have the producer, the DLL to be created, and then whatever is required for running the producer is part of this base image ASP.NET 7.0. If we go back to the terminal again and we start interacting with Docker, we can start by looking at what are the images that I have on my machine. So there are only 3 images as of now: Redis, Zipkin, and Dapper. These were the ones which we used last time as a result of running the Dapper init command. I don't have any image related to Dotnetcore or .NET. So to get started, what we can do is we can use the docker build command to build our custom image using that Dockerfile. So if I list down the contents again, I'm in the same location where the producer related Dockerfile exists, and we are going to use the build command now to build this. The docker build command is very simple. We use docker build and then we provide a tag. Tagging is a way of identifying our images or putting like a version on the image, and then we pass the context, which is dot, which means whatever is there in the current folder or directory is passed as a build context to the docker build command. And we see that it is pulling this mcr microsoft.com.net ASP.NET 7.0 image because I don't have it locally, and then it does the copy operation from the release output folder. It copies all the contents into the root level of that image, and all these are created as different layers. So all the instructions that we add, they get added to our image as the layers. Now if I run the docker images command, our image is created, and it is tagged as the producer image. So when we run Docker images, we should see a new image created. So we can see the producer is the new image which is listed here. The tag is given as latest. If we don't specify any tag at the time of creating the image, it always has a default tag as latest, and it has an image ID. We can see that it was created 45 seconds or 43 seconds ago, and the size of that image is 220 MB. Let's clear all this, and let's see how we can run this image. So in order to run the image, now if you remember from the previous discussions that we had, the image is like a template. We still need to convert that image, or we need to run the image, and the running version of the image is called as a container. So if I want to run, I can use the docker run command to run the image. So let's run this command here, where we say docker run. RM is to remove the container once it is finished executing. We are also creating an interactive terminal into the standard output of that container. We are going to name the container as producer, and we are mapping 5000 port on our local development machine to the port 80, which is exposed by the default ASP.NET image, the base image that we are using. And we are passing the environment variable, which is ASP.NET Core environment, and we are setting the value as development, and producer is the name of the image that we just created, which we want to run. So we can see immediately in no time the image is up and running, and it gives us the log of that execution. We can go and hit the local host and 5000, which is the port map to 80, and we'll be able to see that this particular producer application is running. So if I go back, I have the Swagger UI enabled for that application, the producer. We can see that there is a generate and the test methods on the producer API. So that shows us that the image is now being converted into a container, and we have a running container, and our application is running inside the container now, unlike last time when we were running it locally on our machine. There are some things which we would like to improve in this, or we would like to change. That's the simplest way of building a Docker image, where we use the base image from whoever is the provider. In our case, it is .NET ASP.NET, and we copy the output of the build. The problem with this is we need to have the build tools on our machine in order to do that. And in today's modern day processes, or the way we build applications, is we use a continuous integration and continuous deployment CI/CD pipelines, and it becomes very easy to replicate this kind of build if we can reproduce this build outside of the dev environment. And for that reason, we are going to use a slightly different version of the Dockerfile. Let me switch to version 2 or V2, where we will build the application itself as part of the Docker image. This is called as a multi-stage build, where we separate the build and run stages. So let me walk you through the multi-stage build version of this file. I've created this file as Dockerfile V2 Tech Talks producer. So we start again with the same .NET version of the image, but instead of using the ASP.NET, we are using the SDK image, because we are trying to build the application as part of the Docker build process. So we name this, the first image reference, as the build environment. And since we have the run environment or run type of settings later, that is why this is called as a multi-stage. So the first stage is the build. We define a work dir, or working directory, inside this SDK image as app, and then we copy the producer's content, whatever is inside the producer folder. So let me go back to the terminal again, and let me stop this running instance of the Docker. Let's clear the screen, and let's go one level up. where this Dockerfile is located, and let's list the contents of that folder. So we have the solution file under the .NET, and we have the producer and consumer at the same level. We also have the TechTalks model, which is used both by the producer and consumer, and the V2 version of the TechTalks producer Dockerfile is here. The reason I have created it here instead of creating it inside the producer folder, because when building, we have a dependency on the TechTalks model, and we are not just using the producer code, but we also need the TechTalks model, and that is why this file needs to be outside of the producer folder. So let's go back to the Dockerfile which we were looking. Once we copy the contents of the producer, we also copy the contents of the TechTalks model, and then we change the working directory to producer, and we run the .NET restore command. So if you remember last time when we were building the application, we run the .NET restore command in order to restore all the dependencies which are required or which are referenced by my application, like the Dapper dependency which we added, and any other dependency that is part of my application's build process. It would be restored from our NuGet repository or NuGet registry. Then we use the publish command. So the same command that I ran earlier, the .NET publish with the release configuration and putting the output in the release folder, we run it as part of our Docker image now. As a result of this, the release output will be created and it will be part of the release output folder. Once the release is created, or once the DLL is created, once we have the artifact ready, we don't need all the build tools. Now the SDK image contains the build tools which are required for building .NET application. When we run the application, we need a small set of the runtime. We don't need all the build tools to be available in the production environment. And that is where we switch from the SDK image to the earlier version of the ASP.NET image which we had used in the default Dockerfile. So here we start again from the Microsoft.com.NET ASP.NET 7.0 tagged image for the ASP.NET, not the SDK. And then we create a folder or working directory inside this ASP.NET based image, which is named as producer. And we copy from the build environment. So if we look at the first line, we named our first stage as the build environment, which contains the producer release output folder as a result of running this .NET publish command. So we copy that release output and we put it inside this producer folder. And the last part that we do is same as running the .NET command with producer.dll, which is the entry point, which means that when the image is created and when we create a container instance of that, it will use this .NET producer.dll to execute the process. So with this, let's go and see how we can build this V2 version of our Dockerfile. So for this, again, I'm just going to copy an existing command to avoid any typos. So let's clear this. We are in the producer, we are in the .NET folder which contains producer, consumer and all. So let's run the docker build command, and this time, since we are not using the conventional Dockerfile as the name, we have to specify the file as a command line parameter with the complete file name, which is Dockerfile V2 TechTalks producer in our case. And it's also a good practice to tag it. In the earlier case, we were just tagging it as producer, but instead of just giving producer, it is also better to specify the name of the container registry where we will be publishing this image later. So in case of DockerHub, the default is dockerhub.io. So we don't have to specify that, but I want to use Nilesh Kule as the repository inside that DockerHub container registry. So I specify Nilesh Kule, then the name of the image, which is TechTalks producer, and I want to version this or tag this as V2. And then finally we pass the current folder as the context to that. So again, I don't have the SDK image for .NET. So it is going to pull the SDK image for me, and it's going to extract it. It will perform all those actions that we specified in our Dockerfile, like creating the working directory for producer and each of these will be added as the layers in that image which is getting generated. So once this is over, we will have a different version of the image. So let's go on to another tab in the terminal and run docker images to see what we have currently. So we have the producer and the 3 Dapper related images. Producer is tagged as the latest, and the current command that we are running, it is going to tag it as V2. So now the .NET run restore command is running, and we see that before that it has run the work directory app, then the copied producer into the image. TechTalks model is also copied. So whatever steps we mentioned in our Docker file are being executed as part of the Docker build. So if we go back here, these are exactly the same stages or the steps that we specified as part of our build process, and that is what is happening currently. And finally, our image is ready. We can see in the last line here that naming to docker.io Nilesh Kule TechTalks producer V2. Now if we run the docker images command again, we should see the newly created image, which is Nilesh Kule TechTalks producer, and it is tagged as V2. You can see that there is not much difference between the latest and the V2 version. The latest image is of the size of 220 and the V2 version is 221, because it's basically using the same base image, which is the ASP.NET 7. Now, when we look at these sizes and when we look at the size of other images that we have, like the Redis, the Zipkin, and the Dapper, except for Dapper, the Redis and the Zipkin image, these are quite small compared to our application image. So we can also reduce the size of our application image or our container to a much more smaller size. Before we do that, let's go and look at the contents of the current images that we have. So I'll head over to the Docker desktop and let's see what we can get from the Docker desktop. We will see under the images, both are new images, the latest and the V2 version are shown. Let's first look at the latest version. If I click on that image name, we can see the complete hierarchy, how the image is built. It is built on Debian Linux flavor, and it has got 11 different layers. These are the initial layers which are part of that base image, like get, apt-get update, installation of the software, then the way environment variable for ASP.NET Core URLs is published. All these things are coming from the base image, but if we look at the last 2 lines, the one where we copy the release output, which is about 8 MB in size, and then defining the entry point. That is what we did as part of our addition to the Docker file. And then it also shows on the right hand side the number of vulnerabilities that exists in this image. This is a good addition to Docker Desktop, which I've seen recently. It also tells us that probably these packages which are contained inside the base image, they have some vulnerabilities. It can be high, medium, or low, and we can look at the details of that if required. We also have the list of packages which are part of this base image, and since this is a Debian based image, we can see there are packages like the audit, then the password, bash is there, bzip. All these Linux utilities are packaged as part of the base image which we are using. Now, when we run application in the production, we don't really need all these utilities. Like I don't need something like diffutils, or I don't need find. All I need is a very minimal set of core runtime requirement which is required for running my application, and then the binary of my application. We can reduce the size of this image by using the tags. So if I go back to the browser and we look at the feature tags again, the .NET image which we are using for ASP.NET, the runtime version of the image, it has different tags. If we scroll down below, we can see the full tag listing here. So there are tags like 7.0.2 bullseye slim, there is 7.0 latest, there is Alpine, Alpine 3.16. So the first 4 are related to 7.0 version of Dotnetcore, and the remaining ones are related to 6.0. Since we are using 7.0, we can choose one of these images. So the OS version used by these base images is also specified here, like Debian 11, Alpine 3.17, Alpine 3.16, and Ubuntu. We can choose one of these as the base image. So let me choose Alpine, for example, and the Alpine version of the image, I have created another Docker file which is called as the V3 version. So the reason for using Alpine is, again, Alpine is one of the smallest Linux distribution. They don't have so many packages that we saw in Docker Desktop similar to the Debian one. So I'm going to use in the multi-stage build, again, the SDK image based on Alpine 7.0 or tagged as 7.0 Alpine. Rest of the process remains the same, where we copy producer and the model, we restore the project, we publish the release artifact, and then we copy it into the Alpine based runtime image. So here, instead of using ASP.NET 7.0, we are using the 7.0 Alpine tag, and the rest of the part remains the same. So let's go and build this version of the image and see what difference does it make to our overall size of the image. So going back to the commands, let me copy the command for V3 build, and let's go back to producer, clear the screen, and fire the .NET build command for V3 version. So once again, we see that the SDK Alpine image was not available locally. So it will pull that image and it will build the application as per those different steps we specified in the Dockerfile. So let it get built, and once it is ready, we will go back again into the Docker desktop and see how much change did we manage to get. So once again, let's first run here Docker images and list all the current images that we have. So we can see we have the producer, which was the first V1 version of our image, where we directly copied the output of our build or the release. Then the V2 was where we had the build itself happening as part of the Docker file or Docker build process. And both these images are 220 MB, almost 220 MB in size. So the build for Alpine is still running, Alpine version or V3 version. Depending on the size of the project, this could take some time, but the advantage here is I don't need to install .NET SDK or .NET runtime on my local machine. Although I have it for better convenience to have a good developer experience, I can use Dockerfile to build this source code just by using a code editor without installing anything related to .NET. That's the beauty of having a multi-stage Docker file. I can take that Docker file, multi-stage Docker file, to a build environment like a Jenkins server or Jenkins slave, and I can build my application wherever I can run the Docker build command. So we have finished the build, and currently we have the V3 version of TechTalks producer created. Let's again run Docker images on the command line, and we see the V3 version is tagged here, and you can see the difference in the size. The earlier version of the images were 220 MB. This is almost 100 MB smaller. In terms of the application, there is no change. The code is still the same. The artifact that we create is almost of the same size. But because the number of packages in the Alpine image are different compared to the Debian image, we see the difference in this size. So before we head over to the Docker desktop, let me show you one more command which we can run on the command line itself, which is docker inspect. And since we have the V3 version, I can use the name of the image, Nilesh Kole Tech Talks Producer and V3 to inspect the contents of this image. So whatever we saw in the Docker desktop, similar information is presented on the command line here in terms of what are the different things related to this V3 version of my Docker image. So let's go into Docker desktop again one more time and see this or compare this Alpine based image. So just for our reference, we can see that the release output that we are using is about 8 MB in size, and the older image, the V1 or V2, it has got 165 packages here. This is the Debian based image. Now let me go back and let's look at the V3 version which we produced just now, or which we built just now. The release output is still almost 8 MB in size, so there is no change in what we are producing as our application's artifact. That is exactly the same in both versions of the images. Now, what is the difference from the previous one compared to this Alpine? We can see this has no vulnerabilities, and in terms of the packages, there are only 54 packages in this Alpine image. So that is the difference in having a different base image or using a base image with a different tag. Now, depending on your project requirements, you can choose the right image which is required for you. Alpine might not be suited for all the cases. You might have, like in your organization, Ubuntu or Debian might be a standard. When we use CI/CD pipelines and when we have things like DevOps or SRE teams, usually bigger organizations, they tend to create the curated base images where they are hardened and they are published as the organization's base images instead of using the publicly available image. So in that case, if you want to use, let's say, a different version, we can also do that. And for that reason, I have the V4 just to show that if we want to use a Ubuntu based image, what change we would need to do. So the first part remains the same. I'm using the SDK image here, and then when it comes to the runtime image, I'm changing the tag here to 7.0 Jammy, which is related to the Ubuntu image. So if I again go back to DockerHub where all these details are published, I can see the 7.0 tag or 7.0 Dotnetcore for the Ubuntu OS 22.04 has this tag as 7.0-Jammy, and that is the one I'm using here. And once we build, again, we will have the same process followed like we saw in V1, V2 and V3 of this Docker build process. I'm not going to run it again. In case you want to try it on yourself, all this is published in my GitHub repository. You can copy the command from there and you can see the output. Now, one more thing I would like to show before we close down this session is how do we run this and how do we make use of this. We have created the Docker image or Docker images for our application. In order to run, I just showed earlier the run command. So let me show you another version of this. I will keep the command simple. In the earlier version, we were using the -it parameter, which is for interactive terminal. This time we will use another version, which is called the disconnected mode or detached mode. So let's see how we can run the Docker image. So in this case, I'm going to use the detached mode, which is not going to provide us integration with the terminal of the Docker container with our own terminal here running. The name, the port and the environment variables, they remain the same in this case. The only change I have is the name of the image which is being used, and I'm going to use the Tech Talks Producer V3 version of the image. And we can see immediately it creates this container with a long name and it comes out. So it's like the container is running. We can look at it by running the docker ps command, and we can see Tech Talks Producer V3 is up and running. It started about 14 seconds ago. We can also verify this by going into the Docker desktop and looking at the running containers. And we have the producer, with the image TechTalks producer V3 running. So even though it is running, I don't have access to the terminal of that particular container which is up and running. So we can go back to the Swagger UI and let's run that test again, and let's give a name here. Let's say Nilesh, and execute. Now this is executed and I have the success, and this particular method, it logs the output with the name, but I can't see that output. In order to see the output, I know the name of the container. So what I can do is I can use this docker logs command to see the logs of the container which is running. So the producer is the name of my container. So if I run docker logs producer, I will get this log from that running container, and we can see hello Nilesh as the output. This is one-time output. If you want to tail it, or if you want to follow the logs, we can also do that by just adding the -f flag or follow flag. And in that case, if I go back and execute the same method again, we should see another entry here. And just to say that it is really taking the names and I'm not hard coding it, we can again try a different name and we should see hello James Bond. So that proves that it is actually tailing the logs from the running container. And with that, we come to the end of this session. If I close this now here, the container might be still running. So if we go back, we see under the containers in Docker desktop, the container is still running, the producer. Unlike the last time when the interactive terminal was attached, when we stopped it, the container also stopped. But in the detached mode, the container keeps running. And if you want to stop this, we can stop it from the DockerHub UI or Docker desktop UI, sorry, using the stop option, or we can also do it from the command line. So in the first video, I had given the links to the cheat sheets for Docker. In case you are interested in working more with the command line tools, you can have a look at that video, which contains the links to the cheat sheets for Docker commands. So with that, I have completed whatever I wanted to show during this demo. Let's switch back to the slides and quickly cover up or summarize what did we see. So we started with the Dockerfile V1 version, which is the vanilla version, where we just copy the release output by building the application on our machine and then just using a base image for ASP.NET 7.0 and copying that output of the build into this. In the second one, the upgraded version of Dockerfile, which contains the multi-stage, we built the application itself as part of the Docker build process, and we separated the build and the runtime phases or stages for the Docker. In this case, we use the default 7.0 tag for SDK image and the ASP.NET, which is based on Debian, and we saw that there are some packages which are default in that particular version of the image. Then we optimized it by using Alpine as our base image, and in the Alpine version we saw that there were no vulnerabilities and the number of packages were relatively less. And the last one, we also try to see if we want to use another tagged version of the base image like Ubuntu, we can do that as well. So in order to run the containerized application, we looked at it in two different ways. One, using the interactive terminal mode, where we use docker run command with -it flag, and then we provide these four command line parameters. First one is the container name, which is producer in this case. The second is the port mapping. 5000 is the port on our local machine, or the machine where we are running this command, and 80 is the port which is exposed by the container. So we are mapping default 80 port on the container to 5000 port on our machine. And then we also provide environment variables like ASP.NET Core environment, and we set the value as development for that. And last is the name of the image. So we are using producer V1, the tagged version of this image with V1 tag. So with that, we are able to run the application, which contains everything that is required for running the application. It has the code or the binary as well as all its dependencies. We don't need anything else. In the subsequent part of this video, I will show, or this series, we will see how to publish these images, and then you will be able to pull that image from the container registry, and you will be able to see that even without having .NET installed on your machine, you would still be able to run this application successfully. So in summary, what did we do is we used a series of set of base images which are provided by major tools vendor. In our case, since we are dealing with .NET, these images were provided by Microsoft, and we made use of those Dotnetcore base images. We used the SDK and the runtime version of the image with different flavors. Then we created a Dockerfile which contains the set of instructions. It tells what are the dependencies for the application and what is the actual application that we are running. We also used the multistage build, where we separated the build and the runtime related artifacts by also using different sets of base images, and this helped us to reduce the size of the image or to optimize the image size. This is very critical in modern day applications because lower the size of the image or smaller the image size, first thing, it is more secure because our attack surface is reduced by having smaller number of all these utilities in that image. And secondly, it helps in the network traffic, since we are transferring images from one machine to the container registry and then we are pulling it to the target deployment environment. If the image is big, it's going to consume a lot of network bandwidth, and it's also going to slow down the process of our deployment. So having a smaller image definitely helps in improving the overall application deployment lifecycle. And in the later parts of this series, we will also see how we can use the multi-stage build to incorporate other facets of the software development lifecycle, like running the unit test cases, running the code scans, running the scan on Docker images for vulnerabilities, those kind of different steps which are part of the software lifecycle build. We can also do that as part of our build process using the Docker images or Docker files, and we will see that later in this series. So in summary, or if there was one takeaway you wanted to take from this session, try to keep your image sizes as small as possible to reduce your attack surface and make your base images or use the right base image for your application. If you want to learn more about these kind of things that I've talked about, this video is part of the Cloud Native Ninja series, and you can head over to the GitHub to see everything that I have shown in terms of the code. It's all published on public GitHub repository named as Cloud Native Ninja. The slides are available on SlideShare and Speaker Deck, and hopefully you found this useful. If you want to learn things like this, there are various other videos I have done, like 15 factor apps, what are the main characteristics which help us to build cloud native applications in a resilient, scalable manner. Have a look at that video or those videos, and let me know in comments if there is anything specific you would like me to cover as part of Cloud Native Ninja series, or anything specific to Docker for that matter. Thank you for watching this, and until next time, code with passion and strive for excellence.